Hi guys, we are taking a look at this question where four metallic bars suspended freely from a ceiling interact, and they are shown here in this little diagram. The points of attachment X and Y are 4 centimeters apart. Alright, so the points of attachment are 4 centimeters apart, but the blocks itself are 5 centimeters apart. The two bars in the middle are magnets X and Y, and the distance between them is 5 centimeters. One of the bars, A or B, is made of iron and the other is made of gold. 9.1. Write down the term describing a material that is easily magnetized, and we call that ferromagnetic materials. Okay. Sorry, just one C. 9.2. Which one of the bars, A or B, is made of iron? And that will be B. Why? Because you can see how attracted it is to that magnet right there, or how the magnet is attracted to it, either or. 9.3. Determine the polarity of bar B closest to bar magnet Y. Write only north or south. And the answer is south. And in 9.4, you have to explain that answer. So if we take a look here, we can see that X, it has north on the left side, so it has to have south there. These two repel each other, so south has to be there and north has to be there. Because Y and B attracts each other, S has to be here and N has to be here. And that is why that is south. So you can actually draw it for them and write down all these north and souths, or you can tell them that magnet X repels Y, so that means magnet Y attracts B. But I think it would be easy to just write the north and south. It's more visual, but whichever you prefer. Okay. 9.5. Sketch the magnetic field pattern around magnet X. Okay. So it's just one magnet they want. This is our magnet. You can draw it nicely. On the one side, you have north. On the other side, you have S. Okay. So very interesting. What they want is they want the correct direction of the field. They want the shape, and they want no lines have to cross, guys. The lines cannot touch one another. So how do we do this? We start on the inner corner. We do that. And we go at the end. Yours will probably look slightly different than mine, but as long as the lines don't touch, we are good. Don't forget to draw your arrows north to south, north to south. Then remember, we still have the outer edges. Remember, one has to go straight and then like that. See, none of them touch. So these will go inward, remember, and the norths will go out. So just draw a similar pattern and the norths will go out. Very easy 3 marker there, guys. So this is how one bar magnet should look like. Okay, 9.6. We have bars A and B are now removed. So these bars are now removed, and what we have left is right here. Okay? And the points are now narrowed, and they are not 4 centimeters anymore. They are only 2 centimeters. 9.6.1. How will the change in position of the attachment affect the final distance of separation between the bars? Write only greater than 5 centimeters, less than 5 centimeters, or remains at 5 centimeters. So the answer is less than 5 centimeters. And in 9.6.2, we got to explain that. So what you can say is, when there is a decrease in distance, our magnetic force increases. B is no longer attracting Y to the right. Okay. Or you can say the magnitude of magnetic force is inversely proportional to the distance, and B is no longer attracting Y to the right. Okay. And that's it, guys. See ya.